The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody, and this is Dr. Mansour, and today is June 28, 2020, and this is the last session of the free webinar series, or free workshop series I offer this summer to keep everybody busy and preparing for the exam. I hope that it was a successful story or a good idea. So the just I did not get a chance to scan and send you the notes I prepared or I took yesterday, plus the two um, um, tables or the two methods of the soil classification, the AASHTO and the Unified Soil Classification System, the one we talked about it yesterday. So, but I will do it today. I got distracted yesterday by too many things. Even I left early, but still too many things, including the allergy, which is bothering me too much. But what can we do? This is the price that you have to pay when you live in the Central Valley for California. Construction. This is the 8th edition I was referring to yesterday, the ACI formwork for concrete, the 8th edition. And I showed you yesterday the 7th edition. The 8th edition is a current edition, and I updated my books based on that. This is a little bit better than as far as its color, by the way, number one. Number two, they added a little bit and modify a lot of stuff. So try to do your best. And this 8th edition, I know even it is an expensive book. It is SB4. It is a special publication for 2014, published by the ACI, the American Concrete Institute, as all of you know. It does have at the end another reference among the 8 references listed by the NCEES. They have the ACI, let me see, 318 after this appendix. Here it is. So Appendix E. In the Appendix E of the book, they have a guide to form work for concrete. This is the specifications ACI 347R-14 by the ACI Committee 347. I participated in one of these committees way back when I was in Las Cruces in Mexico. And in fact, also you'll find the new reference they added, which is the field work, the field reference manual. This is also ACI. They replaced this reference with 2 references, in fact, NDS and the ACI 318. So the ACI 3 is called Field Reference Manual. Specifications for structural concrete. And this reference, by the way, it's available. You can purchase directly from the ACI. I don't know how much they sell. Also, this is one of the expensive books, as far as I know. You will find it is a series of specifications. They have it. And in fact, 347 is one of them, as far as I know. And maybe at the end you will find ACI 347 maybe is repeated again, the one I was telling you about. Yeah, here it is. So these are the specs that they included in this book, because they have committees after committees after committees in the in the concrete area, the ACI committees. So here they are, 301, 311, 117, and so on. And the 347 is repeated here again. So 347 R-14, it is a guide to form work for, is in SB4 also, the book. So you will find this is in two different references, this reference and the other reference. So I know, and it is not an easy for me to tell you which reference to take to the exam and which reference is critical. Do your best. For example, the ACI, sorry, the ASCE. Excuse me. The ASCE, okay, 37-14. This is the design loads on structures during construction. Very small publication published by the ASCE. It has the same blue color like the ASCE 7-10. The minimum design loads for building and other structure, but this is only loads during construction. So this is a serious issue, and I summarize this document into my book. Very good as far as I know. I did my best, but I cannot claim anything other than that. Another small publication for masonry, it is a bracing masonry walls during during under construction. Is this another reference? So sorry, here we go, probably the okay. So and this is the list of references, as all of you know, listed at the beginning of the NCEES or the under NCEE. At the beginning of my books, normally I include these references. Let me see, here it is, the NCEES. Here we go. Yeah. So those are the references that listed their current test plan, and I really encourage everybody to check with the NCEES from time to time, as I mentioned. So this is the ASCE 37. It is 2014. The masonry, the standard, the CMWB, okay, the concrete for masonry wall bracing. This is what is meant. So these are the two references, the small ones I just showed to you. The steel manual, the AISC, the American Steel Scale, the 14th edition. You don't need the entire, but you need part 1 and 2 and 3. Part 8 is welding, and 16.1, chapter M and N, and 16.2. So, but if you do have the entire steel manual to take it with you, this will be a very good idea, especially the steel manual. Let me see which edition I have here. Let me grab one of these. So this is the 14th edition. It is the red cover, the 14th edition. So try to get hold of the current one. If you are not able to get hold of the current one, try to get the latest one, okay, whatever edition you have. Maybe you will be able to grab one or two questions if they ask questions related to, and I did my best also, because the manual is, or the sections of the manual they are referring to is very thick, and especially for the steel manual, by the way. As you know, the first part, which is part 1 of the steel manual, part 1, part 1 is talking about the properties. So if you go to the steel manual and go to part 1, so you'll find part 1. Let me show it to you. Here it is. Or no, that's called dimensions, sorry. Okay, dimensions. Yes, dimensions and the properties. Oh, I remember the word the properties. So part 1, dimensions and the properties. Okay, so part 1, dimensions. And properties. Dimension and the properties. So this part here, basically it has the dimensions related to different structural shapes, W shapes, C, and angles, and so on. So S shapes, HB shapes, all these are the properties that WT, the rectangular, okay, hollow angles, and so on. So it is better to or try to get hold of the this part, take it with you, um, at least um, as a minimum. Let me put it that way. But if you can get the entire steel manual, I know it's expensive. Steel manual, the 14th edition, even they have the 15th edition, by the way, the 14th edition. If you can get hold of it, it will be a good idea, or carry it with you, or take it with you. Because sometimes they ask questions related to this. And if you don't have the section talking about dimensions, you will not be able to answer the problem. For example, you might be asked about the W shapes or the S shapes, or HB shapes, especially HB shapes, the piles, okay, HB shapes. Let me see if I can locate them very quick. So the HB shapes, that the one they use it for the piles, double angle, 2MC, WT, different. Yes, and they try to put some kind of tabs to make sure that you are locating the sections quickly. I believe it is after W shapes. Let me double check. W shapes and M shapes, and here it is, HB shapes. Okay, so you can tab it. Okay, so the HB shapes. Okay, the HB shapes. This is the section, and they use it for piles. Okay, for using for piles a lot. Okay. So, and here are the properties. They give you the dimensions and the whatever the section or the shape, HB 18 by 204, and the 18 is not the exact, so it's not the exact height. So when you say HB, for example, let's select a size, which is the first size in this group here. Yes, okay, so it is HB, in fact, the biggest one, 18 by 204. Okay, so the first number is exactly similar for W shapes, by the way. The first number is approximate depth. Approximate depth. Approximate depth, okay? Approximate depth. This approximate depth given as far as the group, the entire group, but the actual depth, this is, for example, the first one, 18.3, 18.0, 17.7, 17.5. So I will not get, or I will not be able to get the actual depth unless you have this book, unless you have, okay, something similar, okay, to this table in this book or other book, whatever it is, okay. So the second number, this is exact, and this is the weight in pounds per linear foot, pounds per linear foot. So if you go to the reference, you will find the 204 is listed here. 204 is the nominal weight, pounds per foot. Okay, so so the type of question that might be asked related to shapes or dimensions in general, or steel structural shapes, it might be related to either the weight, how many pounds or how many tons weight, or some coating, volumes. For example, he will tell you that I have a site that has been selected, okay, to build a high-rise building, and because of the nature of the soil and because of the height of the structure, they decided to use H-piles. So they are going to use H-piles to drive H-piles into the ground. These H-piles are driven by big machine that has a hammer weight, and also we talked about the hammer and the efficiency and horsepower um, um, for in the section of piles of my book. So they drive these piles based on the design spacing and direction and so on to a certain height or a certain depth, certain depth, much better word, depth, height for building, depth for footings and piles. And he might tell you, okay, how many, okay, he will give you the number of these H piles. How many tons of steel is required? And this is very easy and straightforward. But because we know from the the dimension that is given, for example, 18 by 204, and if I remember that the weight, I don't know why the camera stopped. I didn't do anything. The camera is supposed to be still connected and still working. Oh, okay. Yeah, there is something went wrong here. Let me probably let me bring it back again, please. It seems to me that see what happened to the here we go in task. I will bring it back. So if they are asking for the weight, this is an easy straightforward problem, and I believe I do include some problems in my civil breadth AM related to that, and probably I get hold of the many exams I provided and so on. So this is an easy to calculate the weight for W shapes, for S, for angles, and all these things. No, let us see why this. Let me close this first. And open it again. Hopefully it will work this time. Oh no, I know what I did. Probably I did something. Here we go. I know. I learn from my mistakes. Sometimes I push. Here we go. Okay, thank you. Sorry. Okay, so the depth of the piles will be given to you, and they might ask you for the weight. The weight is very easy, as I told you, that because the second number in this scenario here, or this shape here, is the weight in pounds per linear foot. So and it is easy. The coating volumes or coating weights is the challenging one, because you need to get the dimensions, or you should know the dimensions for whatever W 18 by 204. So if this is the shape, this is the structural shape, the HB. Okay, it is HB 18 by 204. Okay, so we need to know this dimension here, and the thickness of the flange, and the thickness of the web, and all the dimensions. So in order to protect these H piles from corrosion, even if the even the steel is treated for corrosion, sometimes we protect them. Excuse me. We protect them with some kind of coating in order to prevent additional corrosion, maybe. So they are saying that if I know the gallon can cover a certain surface area, how many gallons are required? This is one application that it might be. And the coating volume also not necessarily to be limited to piles to be driven into the ground. It could be in the superstructure. You have a superstructure, which is the structure above the ground. Okay, and this is a steel structure. Okay, so by code, we are required to protect the steel from any kind of fire, so to be fire resistance. So in this case also we can spray it with some coating material as a fire protection, the fire protection coating, and I saw this in certain buildings, and the fire is very, very important, so they coat it. Okay, again, so they put a coating in order to protect these steel beams and girders from yielding in case of fire, so the building will not collapse. So he will give you the dimension or the dimensions of the steel members, and after that he will ask you how many gallons of the fire protection, for example, or the fire coating. If we know the gallon, 1 gallon can cover a certain square foot surface area, whatever is the surface area you calculate. So in this case, I need to get the parameter of this multiplied by the depth or the length, because this is like this. So in this case, we can get the surface area, okay, because I need to get the area. The area is equal to the parameter times the length. If I don't know the dimensions, I will not be able to get the parameter, because the shape itself, the 18, even this depth 18 here is not the actual depth. In fact, this is an approximate depth, is 18, so it's not exact. It's not. You have to get it as I mentioned. So try to get, do your best to get the steel manual, to take it with you into to the exam site in order to. So going back to the list of references, since this is the last day, let me just go over this. It is your decision. Normally, I say that is a very difficult task for me to tell you what reference should be taken or what reference should be. I did my best as far as my books. In all my books, I try to extract as much as I can within the copyright, whatever copyright issued to us. Somebody is handling this for me. My lawyer is handling this for me. And whatever the copyright is permitted, or whatever legality is required, he knows the law, and what is permitted and what is not permitted, and what is legal and what is illegal, and all these things. I don't handle it. So in this case, try to do your best. The ACI This is the field reference manual, the one I was telling you, 2015. This is the one it does have. So this is the ACI 347 R. This here, it is, you see, I put here, it is here and here, by the way. This is the ACI SB4, which is the color new edition. This is among the expensive books, as I mentioned. And OSHA, this is very easy. I recommend you to buy OSHA, the current one, because they change it, and try to do your best to get the current one. And finally, MUTCD, this is also cheap, part 6. You can get the entire book for about $40 or so. So you need only part 6, which is related to traffic control devices. The temporary traffic control zone. So the temporary traffic control, the TTC traffic control, temporary traffic control. This is in this book here, part 6. It does have a lot of scenarios, and I believe I included some of them in my books. For example, the AMBM book for construction. I believe I included some cases, yeah, but not many. I think in the textbook I included more. I know there is one book I included more than the other, so probably the textbook I included more in the summary, maybe, or probably in the AM book also I included a lot of cases. So I will be glad to send these cases to you. So I do have many cases. Which book is that? Oh, this is a civil bridge. I'm sorry. I'm looking to the wrong book. Let me look to this book here, which is a construction book, because I remember I included too many cases. Forgive me, because too many books, and no, I included only not, no, so it's not too many as I claimed in the summary. Yeah. So probably I do have a very good summary of the. Let me see if they are included here. No, they are not. So I will be glad to send it. I think I know where they are located. So those are the 8 references. Those are the 8 references so for those who are in construction, you are very welcome to take as many as you want. I did my best in my books, and hopefully that this is my books were way back in 2008. I was the first one who came up with construction books after they introduced the construction as one of the options for the PM. So I'm still improving and enhancing my books as usual. This is the only thing I can claim. I cannot claim anything other than just I'm doing my best. It seems that one of you has a question for me. Okay, is the new edition of the IEC change a lot? I cannot say the max. I cannot. Normally, I don't answer these questions because one little tiny change, I don't really compare it one by one or page by page. So it's very difficult for me, Max, to answer that. So normally I say that it's very important to get the latest edition or the edition as listed in the NCAAS, because I'm really afraid to tell you, okay, they didn't make too many changes, or they make this change and this change, a little tiny change. It could be a liability on my end. So sorry, my friend, I cannot really tell you exactly what the changes they made, because I cannot claim that I am aware of every single change in any book when they come up with a new edition. Normally, okay, I focus only on the material related to this and they try, but to go back again and compare it verbatim one by one will be very difficult, and I'm afraid to miss one little tiny change. It could be my fault that I didn't pay attention to, so it could be a liability issue, and I don't like to be liable. So normally I say that please do your best to get whatever list they provide as far as the list of references, and this is true for transportation, for construction, for geotech, for structures, for all other discipline. I prefer always to say stick with the latest one, stick with the listed one, list of references, because I cannot really claim that I'm aware of all the changes. It will be very difficult for me to make this claim. Okay, so this is so I do have, as I told you, the thing that I can send the tables from this document. We have many tables in the SB4, tons of tables of the SB4 design tables, and I will be glad. I think I do have some tables has been reproduced from here with the copyright, and I believe I included some of them in my textbooks. And I will be glad to include these tables. Does have some tabulated values based on testing and based on standards. For example, nailing is a very good area. I can refer you to this section when we drive nails or put ties. In this case, we need to make sure that the nails are penetrated to the proper depth and they are capable of supporting the load. So in this case, we can rely on the strength of the connection. So, and they do have some problems. For example, let me show you. If you have two pieces and you need to connect them, and there is a certain load, so you drive a nail, okay, and this nail sizes, as you know, nail sizes, I include them in my seismic book, by the way, in chapter 10 of my seismic book. Even I know this is not a seismic class, but I'll show you the picture. At least you see what is the nail size we're talking about. They have the table. I will show you the table right now. I have a full size. Here it is. So nails, and also a picture from the ASCE and the ACI and Simpsons. But basically nails, either common nails or box nails. So the nail chart, normally it does have what is known as the penny nail. So it is 20D, 10D, 16D, and so on. And they give us the dimensions. So when you drive a nail, this nail has a length, it has a parameter, and okay, it does have what is known as the gauge, the wire gauge. This is for common nails. So what they did, in order to calculate the capacity of the nail, that if they drive the nail in this piece of wood and we drive it to a certain penetration depth here to make sure that it will not be pulled out, to support the load, whatever the load is. So if you do have this configuration, okay, you have a piece this way and a piece this way, and there is a load here, P. Okay, and we need, okay, and this is, for example, let's assume this is fixed from one end, okay, and we need to support or to connect these three pieces together. So we drive nails here. Okay, so the nail does have a length, and it should go through this material, and it should go into the other member a certain penetration depth. It's called penetration depth, and they did something. It's called pull-out test. Pull-out test. They have tests, okay, like concrete also for the development length. They did a lot of testing to make sure that the development length for rebars are provided, otherwise it will be pulled out during an earthquake or during load or something like that. So what they did, and I used to do this, by the way, with my students back in Las Cruces, New Mexico, to determine the capacity of nail connection. I give them 1 by 8 or 2 by 8, and ask them, and they test it, and these nails will be spaced. And we are using this equation. Tau is equal VQ over IB, by the way. This is the horizontal shear stress. So we calculate that. We calculate the horizontal shear stress, and we can calculate the spacing between nails S. Okay, if you remember from mechanics of materials, we covered that also in mechanics of materials, how far or the spacing between them. And they developed a lot of tables related to this. The SB4, they did the same thing, but in this case, they take into consideration the whatever they call it, the moisture. Moisture is very, very important. So they include the moisture. How much is the effect of the moisture? These tables are really chart. Also, these charts are very important. There are too many things, but let me, if I can locate the nails very quick, at least to give you an idea. So this is what is here. For example, this is a box nail. This is a common nail. Here it is, the box nail and the common nail. The common nail is, as far as diameter, is um, normally okay for the seam gauge. If this is 10 and this is 10, the diameter here is bigger and the circumference is bigger. This is why the capacity of the common nail higher than the box nail. This is called double head. Okay, they drive it, and this is the second head here where they can pull it up. They drive it, this will stop, and they did that in order to take it out during. Okay, so they came up with tables, and for example, this table here for 17 nail sizes and measurements, and they go with the also the D, okay, 10D, 12D, and so on. So they give you, so this is a table that we need. And this is, here it is. This is a connection I'm talking about. Okay, so withdraw, okay, value, or it's called pull out. Okay, so and they have an equation, and here are some moisture and duration adjustment factor for nails and screws. These tables are really, really important in order to calculate the capacity of a connection like this, and I solve problems related to this, and so on. The toenail also, about the toenail dimensions, what the toenail is, toenail, and what is the requirement for the toenail also is given here. So based on testing and based on analysis, they came up with tons of tables. And I don't know, for those of you who took timber design, there are two important equations. A professor, okay, the strength value can be calculated by Hansen. Hansen formula is very, very important. These formulas, two formulas here, okay, we calculate Hansen's formula. This is Professor Hanks, and they give a connection like this and calculate the capacity and so on. So I doubt that they will cover this in timber design. Timber design, for those who took timber design, I cover Hanks's formula in the timber design book, which is one of the references for seismic book, but is not required for seismic to cover Hanks's formula. So this is why I don't cover. Anyhow, I do have tons of tables from, or many tables. Now I don't like to say the word tons. So I have some tables taken from the SB4, and I will be glad to include it SB4. So tables, I will be glad to include whatever I obtained copyright for, and in this case, I can send it to you. And also from the MUTCD, I do have MUTCD traffic, temporary traffic TTC, temporary traffic control from part 6. Also, I have a lot of, so I can include this with whatever material that I wrote yesterday, and we'll take it from there. The one topic that I was talking about yesterday, which is related to materials, we talked about the how the amount of carbon in steel is affect the strength. This is something that we can cover it, Muhammad. It is in July the 4th. July the 4th. So the carbon content, the chapter I sent to you, it does have this answer. The carbon content will do the following. For example, if you look to the stress strain curve, and you will find this, by the way, in the chapter I sent to you, if I'm not mistaken. If not, let me cover it very quick here. Let me see if the chapter is here. It was here sometimes. I keep something near me in order to. This is yeah, I did include it. Yes, that's correct. Okay, so I will show it to you. If you get a chance to print the chapter, the one I send it to you, you'll find the answer over there. Because I know sometimes they can ask you. So if you look to the stress strain curve at delta L over L, and this is sigma is equal P over A. So you will find that the relationship between the stress and the strain for low carbon steel is like this. Like A36 steel, A36 steel, which is a low carbon content, Okay. So increasing the carbon content in the steel will do the following. Modulus of elasticity will stay the same. So E stay the same. The yield will go up. This is the yield, either the upper yield point or the lower yield point, and the ductility will go down. So probably this is higher carbon content. And if you increase the carbon even beyond that, even more, you will find the slope is still the same, which is the modulus of elasticity. Modulus of elasticity, sorry. Okay. So if you go with another type of steel that has a high carbon is like this. So the carbon content will do the following. Okay, so E, modulus of elasticity, is the same, because this is the slope of the line. The yield is directly proportional to carbon content or carbon percent. Higher the carbon. Okay, ultimate strength, also it is directly proportional to carbon content. The higher the carbon content, the higher the ultimate strength. The ductility is inversely proportional to the carbon content. Carbon mean that lower carbon, higher ductility. This is directly proportional. This is inversely proportional. Okay, so it is lower carbon content will give you higher ductility. Okay, so ductility is decreasing as the carbon increases. They are inversely proportional. And you can say that the strain at failure also, which is a measure for ductility, a strain at failure is also inversely proportional with the carbon content. The lower the carbon, the higher the strain. As the carbon goes down. Okay, and the handout I send it to you, it is like this, Muhammad. Here it is. If you have, and even by the way, here it is. If question number 94. There it is. Which of the following statements is not true about the effect of increasing carbon content on the properties of structural steel? Increasing the yield stress, which is not true. Okay, if you increase the carbon, the yield will go up. Increasing the ultimate, it will go up. Reduction in ductility and increase the mass velocity. Mass velocity stay the same. Okay, if we increase the carbon, the ductility will go down. So this is a question that you are referring to, Muhammad. Okay, and in a figure or an illustration, here it is. This is a strain, which is epsilon. Normally we use epsilon, which is equal delta L over L, and this is sigma, which is P over A, stress over strain. Here it is low carbon steel. You see this, and the toughness, by the way, I can add also another term, toughness and resilience. Toughness and resilience. I can add additional to sir. The moment it start to this is a medium carbon content. So the curve, you'll find that all of them, they have the same slope. As you can see in the mass of elasticity, is the slope of the linear portion of the stress strain curve. So in this case, this is the and if we keep increasing the carbon content, you will find that, for example, this is a qualitative relationship between not quantitative, not quantities, just to use the low, medium, and high. So the mass of elasticity is still the same. And as you can see, the ductility, which is the strain at failure, or the area under the entire stress strain curve, which is toughness. Toughness is a measure for the ability of the material to absorb energy. Okay, and this is this is the answer to your question, and I will elaborate more when we come on July the 4th. If you join me the July the 4th, and probably I will look at. I didn't get a chance. Also, I scanned it and send it to you as a scanned document. But this is a chapter 9 from my FE book. So I hope that I will remember to send it to you, to send the PDF instead of the scanned. Because the scanned document is not very good quality. Let me ask you, because I looked to the names and I don't know how many of you are taking construction. I don't see too many names today for construction. So I don't like to waste anybody's time. I remember some names, but that's fine. It is your choice to stay because this is construction day. So I prefer to stick with the so this is the effect of the carbon content, and please come July the 4th from 1 to 4, and you will be able to hear more stories about materials and the properties of materials and so on. One topic related to the materials in the construction from my construction book, or related to construction, is I have one chapter here about materials. Let me get it. Materials quality control. Materials quality control and the production. Is the effect of the temperature on concrete. It's called maturity, concrete maturity, and we need to be aware of that. So the section that in my book of the construction book related to the temperature and how the temperature can affect the concrete. So in this case, we okay, sure, I will. The chapter in chapter 5 of my book, talking about hot weathering and hot weathering concrete and cold weathering concrete. Very, very important, especially for construction group. And the temperature loss during delivery. This is something that you might see it on the exam. When they transport the concrete from one location to another, so during the transportation of the concrete, we lose concrete. We lose, temperature. And maintaining the temperature for the concrete is very, very important. So there are many equations has been developed, and this is, by the way, also ACI 306R-10. This is the specifications or the committee that he studied that. And if you look to the equation they provided here, it came from a research, by the way, the Swedish Cement and Concrete Research Institute. They performed tests, okay, to determine the expected decrease in concrete temperature during delivery in cold weather. And they came up with these equations. So, for example, for revolving drum mixers, they came up with this equation. I give it equation number 42. Excuse me. So T 0.25, okay, TR minus T sub A. And for covered dump body is also another equation. These are empirical formulas, by the way. They did a lot of research and they came up with these equations in order to help us to determine how much temperature or loss in the temperature due to transporting concrete. For open dump body, they have to give you this, by the way, in the problem statement. They have to specify this. Okay, so these are the equations that, and the parameters related to these equations are given here. So I need you to be aware of that. Those of you who are taking construction, I highly recommend you to look to these equations. And I included some problems immediately related to these empirical formulas. Problem, for example, number 29. A basement, okay, project 1 hour away. The required delivery temperature to be 45 Fahrenheit, and the outside air temperature is 25. Okay, so according to the ACI 306R, okay, at what temperature, concrete temperature, before leaving the ready mix plant should a revolving drum mixer be mostly? So the concrete should deliver, or the concrete at the job site to be at 45 Fahrenheit. And the temperature outside, the air temperature is 25 Fahrenheit. So we need to determine the temperature of the concrete when it leaves the ready mix plant. So it will lose temperature during the transportation, and this is 1 hour away, by the way. The time is 1 hour because we need to know the travel time. So this is the equation. So I know this is 45, and I know this is the 25, which is the air temperature. So it is, I am losing 5 Fahrenheit or Celsius here per hour. So I have 1 hour So 1 hour times how much I'm going to lose, it is 5 Fahrenheit, since the plant is 1 hour away from the delivery point. I add this to the temperature that I need to be at the job site. So the 50 Fahrenheit is supposed to be the temperature that the concrete will leave the plant having this temperature. So again, if you don't know the equation, where is the equation? I know the calculation is so simple, but we need to make sure that we are aware of the equation and how to use the equation and so on, and the type. So there are 3 equations. I included 1 problem each related to whatever application or whatever method of transporting concrete, and you should know that. I don't expect this for transportation BM because it's not included in their transportation BM. So this is something that I needed to be aware of. And they include a lot of problems related to this. Another area also for construction group, since we're talking about materials, and it is something is called maturity. Okay, maturity. And maturity, I covered it at the end here. Here it is, something also you might it's called concrete maturity and the early strength evaluation. All of us, we know that the F sub C prime, the one we are talking about, is the strength of the concrete after 28 days. So the cylinder that we prepared in the lab, and we apply the load B, and we say sigma, which is F sub C prime, by the way, is equal B over A. So this is after the 28 days. We call it 28-day compressive strength. So are we going to wait 28 days? Yes, you can if you want, but we can do some kind of testing to accelerate the strength. And this is why they came up with, for example, the S7, which is a 7-day strength. The 7-day strength, by the way, it's about 2/3 of the S28. So after 7 days of curing the concrete, you will find that 2/3 of the 28-day strength will be obtained or will be achieved and this is roughly equation, or this is very, but the exact equation that S28 is equal to S7 plus 2.5 square root of S7. This is an empirical formula developed by the ACI code also, where here it must be in megapascal, MPa. The equation, they developed it for megapascal. So you have to convert it to a PSI if you'd like to get it in PSI, but this is an empirical formula. So if I know the 28-day strength, sorry, the 7-day strength, I can predict the 28-day strength based on this equation. S28 is equal S7 plus 2.5 S7. So this is all this in order to know the strength of the concrete at early stage, at make sure that I'm going to get the desired strength. So the strength of the concrete increases with the process of hydration of the cement. Hydration is a chemical reaction between water and cement, as you know. The hydration, as a definition, hydration is a chemical reaction between water and cement. Okay, so the rate of hydration, okay, will increase with the temperature. However, in this case, the temperature must have a limit also. Okay, so the strength of the concrete depends on the age at the time of testing and the temperature of the concrete during the curing time. So they came up with something called maturity of concrete. Maturity. Okay, maturity of concrete. And for the transportation group, construction group, construction. Always I say construction, transportation. There is one problem, problem 5 theory. For those who are taking construction in the afternoon, please pay attention to this. Immediately following a concrete placement, the concrete temperature is monitored, okay, with time. The average temperatures recorded during 4-hour interval are listed below. If the datum temperature is 20 Fahrenheit, the concrete maturity, and these are the units, or this is the unit Fahrenheit hours, at the end of 48 hours is most nearly. So the temperature has been monitored over time, the first 4 hours, from 4 to 8, and so on. So he's asking what is the concrete maturity. So we have equations. Okay, so the ASTM, so the concrete maturity is defined as the summation of the product of time and temperature. Maturity in degrees per hour, Fahrenheit or Celsius. And per ASTM, there are two methods. Okay, one maturity function is based on the temperature time factor, and another one which is called equivalent age. And we have two equations. The equation 43, which is M sub T, the temperature time factor at age, is equal the sum of T sub A minus T sub O times delta T, and we define T sub A and T sub O. T sub O is the datum or the reference temperature. And the second equation, it does have this exponent, okay, of the power E, and the parameters are defined here. Okay, so we have to be careful about that because this is something very important. So I included some problems. I talked more about the maturity of concrete versus compressive strength of cubes. Normally in the United States, we do testing of cylinders. We don't do cubes. The 6-inch cube, they do it in Canada and some European countries. I did some research on cubes, but because I was doing research on concrete using a triaxial testing machine for the Air Force. So we're using cubes where you can load the cube into 3 dimension. I was loading concrete in 3 dimension. This was an Air Force research project to see the effect of the blast on concrete, okay, for the military installations. So we have cubes, and we loaded Sigma 1, Sigma 2, and Sigma 3. I developed the machine with my academic advisor back home in Las Cruces, New Mexico, Dr. Trena. It was funded also from the Air Force, where we built a machine to load the specimen in 3 dimension and with different variations, and big story about that. Cubes are not common in the state. The 6-inch cube in the state we use cylinder, but the research that was available when this maturity was published based on cubes. So anyhow, so you can see that this is a compressive strength in megapascal. Again, be careful. This is equivalent PSI, and this is a maturity, and this is a log scale. Okay, as you can see, this is a linear, almost linear relationship. This table here shows the procedure for accelerating curing to get the early strength. We can get the strength after 24 hours, by the way. Okay, um, so 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 um, so they came up with these tests where they put the concrete cylinders into boiling water in order to accelerate the strength, so we can get the strength of the concrete instead of waiting 28 days. So they came up with all these methods. This is also ASTM, everything based on the American Society for Testing and Material. And they included some problem. There is one problem here, I believe, very similar to the problem in the NC level ES. I gave you the, or it could be the same with different values. I can remember. Okay, so this is the range, and I believe it's almost the same. And we apply this equation and plug it in, and we ended with this number here, and this is why we selected the answer C, which is a 2528, and here it is. So easy problem. And for those who are taking construction, please pay attention to this. So the temperature loss during the transporting concrete is one area, and the concrete maturity and the high early strength, and the early strength determination is another part. After the break, we are going to talk about temporary structure. One of you asked for shoring and reshoring. I will talk about that. Let us take a few minutes break and come back. Right now is almost 10:10 or 10:11 fact. So let's come back. Okay, 10:25, please. Thank you very much. Take a short break and come back. Thank you. Okay, welcome back, everybody. The chapter 6 of my book is talking about the temporary structures. And temporary structures, those are the structure that will be temporarily installed or erected, and after the construction is over, they will be removed. So basically, they are in place in order to hold or temporarily hold the components of the structure until they gain their strength. This is what is meant by temporary structures. And the one I showed to you, the ASCE 73714, the blue book, okay, the ASCE 73714 is the one is talking about the design loads on structures during construction. However, shoring and reshoring are not discussed here. They are referring to it, but they are not included. They are included in this book here, either the 7th edition or the 8th edition is still the same, as far as I know, except here they put it in color. And also they did something probably to make it easy for us to follow by putting some kind of illustrations, more illustrations and more diagrams. So whatever is convenient for you, it is a preference. But as I always say, that I try to stick with the latest one, because the latest one are especially they have a lot of illustrations and very nice drawings this time. They improved it a lot. At least you can look at it and enjoy it in color. In this case, columns and all these things, beams and loads, and they have a lot of. So for the shoring and the floor loads in multi-story structures, this is what is meant. So as you look here from this picture here, either this picture or this picture, either one of them, this is a multi-story concrete building under construction. So and this is the crane. The type of cranes are very important also for construction PM. Tower cranes and mobile cranes, and the difference between them and the capabilities of each and advantage and disadvantage of each. So in either case, this or this, so as they progress from one level to another, so they need forms. Forms are very expensive, and when they erect the forms, to put the forms in order to hold the concrete until the concrete reach its strength, and after that they move to the following level and so on. So they came up with this idea of shoring and reshoring in order to minimize the cost of the forms and to proceed. So the simplest case that you can look at it, that I do have one-story building, one-story concrete. So we are going to put the forms to hold the concrete, and these forms are supported by some kind of vertical shores or columns. And there is one course, I taught it many times, especially for those who are in construction. It's called force work calculations. It's very, very important because there are many incidents and many accidents, and unfortunately, people lost their life because of the false work calculations were not done right, or as a human, we do mistakes, and due to a mistake or mistakes, the false work collapsed. So we calculate everything, sigma, delta, and P, and all kind of stresses, VQ over IB, shear stress, MC over I, B over A, PL, sorry, it is BL over AE, okay, the pi squared EI divided by KL square for buckling. All these equations, deflection calculations, BL cubed divided by 3EI, all kinds of fancy equations that we developed in mechanics of materials, we apply these equations in the false work calculations to make sure that the false work is strong and capable of supporting the load. So here we are putting concrete, wet concrete. The slab thickness, whatever the slab thickness T, 7 inches or 8 inches or anything like that. And these are the vertical columns or the vertical shores. Sometimes we provide a bracing, by the way, it depends on the location, but let's assume that they are only vertical columns like this. And so we have a dead load. This is called dead load, and we are going to assign D for it. The forms themselves, they have a weight. These are the forms. Normally it is steel or wood, treated wood, so it will not absorb any water from the concrete. So we spray the wood forms with some kind of material such that it will not absorb the water, because we need to keep the water cement ratio in the concrete mix to be the same as we design it for. So, but normally these forms are pre-assembled and ready to go, normally steel. Okay, aluminum, we cannot use aluminum for forms because aluminum can react with concrete. So normally these are steel and already pre-assembled and preformed, and bring it to the job site and they assemble them together. And it's a very serious business to put the forms together. So we have a dead load, which is the weight of the concrete. But there are some people here, like me and you will be here, okay, construction people. And also we have some construction loads. We have some equipment and so on. So we have a live load. It's called live construction load. And we need to consider that when we calculate the strength of these columns. So in a case like this, the entire load is going to go through these columns, and it will go to the ground, or the supporting ground in this case, or the supporting, okay. Sometimes if the soil is very weak, we put big pieces of wood together, block of wood, and these columns are supported by this to get the load distributed over a larger area, so the soil will not sink, okay. So there are many techniques and ways to do it. So, but after I finish this, I will place the concrete, and concrete gain its required strength. I need to get these forms to go to the second level. To the second level. Okay, this is level 1, this is level 2. To build the second and put the concrete and so on. So I need to move up. So if this concrete here is not strong enough, and normally, yes, this is the case, so we replace these shores, these are the columns, we call them shores. We replace them with skinnier columns, and these columns, it will be against the slab itself because the forms are taken out. So before we put the concrete of the second level, okay, and we put all these shores we are going to put something, okay, to hold this. We call them reshores. In the old book, the 7th edition, 8th edition, this is a current one, as you know. So I included both in my book to show you the difference. At least let me go to the, okay, the 7th edition, sorry, the 8th edition has the following symbols: that rigid support, which is normally the foundation. They are assuming that the ground, it is rigid at the ground level. That means it will not deform. And concrete, there are two types of concrete. If freshly concrete, they make it cross hatch like this or hatch like this. And for hardened concrete, they make it like this. For the solid vertical columns, these are the shores. Story of shores and the formwork. And the dotted one, this is the story of the reshores. And this is what they agreed upon in the 8th edition. In the 7th edition, let me get the, which I have it here also. I have a sample of the 7th edition. This is the 7th edition, okay, which is 2005, by the way, the 7th edition. Because I included both because I'm afraid that maybe somebody will write a question and he is still influenced by the older edition and he will put something. The symbols a little bit different in two things. Okay, this is still the same. The rigid support, this is a ground. This is a rigid support, as you can see. And the fresh concrete, they make it like this, it's still the same. A freshly placed slab, but the hardened slab is also, so this is the same and this is the same, but the difference is here. Okay, the reshores, they put it like this, across, is not as a dotted line. This one here for shores and form with the solid ones. Do you see the difference? So we need to be aware of that. For the 7th edition, reshores, they make it like this. And for shores, they make it the vertical support or the vertical columns. Shores and forms. And obviously the forms will be a little bit darker. The 8th edition, as I just showed you, they decided to change the symbols. So the 8th edition, for the reshores, they are using the dotted line or dotted lines. Since I made this solid, so they are using the dotted lines to indicate this is the reshores. For the shores and the forms, it's still the same. These are the vertical solid lines. So these are the shores. So this is just to show you the difference between the 7th edition and the 8th edition for the symbol. I included both in my book, at least you should be aware of. Excuse me again. So the calculations involved in this, they should tell you what condition they have. And they have more than one scenario. For example, this here, the title of this, which will be included in the problem statement if they are going to give you a problem statement related to this, shores and the slabs of multi-story structure, 2 levels of shoring and 1 level of reshoring. So this is 2-1. We call it 2-1. 2 levels of shoring and 1 level of reshoring. And this is why you will find that here, for example, and they put it in a form of steps. So step number 1, they are going to put the concrete of the first level. And let me use a color here at least also. So this is a concrete, the fresh concrete. Here it is. And they have it, by the way, in their books in forms of steps, which is, this is exactly verbatim from the 7th edition. This is the 7th edition, as I mentioned. So a place level 1 concrete, full load is transmitted to the ground by shores. And here, by the way, they have what is known as a D. They use all loads in a form of a D, dead load. So what is D is the weight of the slab. If they have life load, they will give you L, as we're going to see it in another examples. Construction life load, like people who are, or the workers, or the staff who is doing the work. So if you have a D here, and this is completely, okay, this is a form here, and the forms are supported by vertical columns, we call them shores. So load on a slab in a multiple of D. This is a slab which is a freshly concrete. The slab is carrying nothing. So the slab, this 0 here, this is related to this. How much the slab is carrying. Okay, because this is a fresh concrete. So the load entirely is going to be supported by the shores. So the slabs are carrying. This one here, and when I hired the people to draw this for me, I was telling them that even the new one, we did a little bit better. I believe they put a dotted lines. I asked them to put dotted lines. It is somewhere in the other edition, probably, or another. I asked them to put dotted lines. Yeah, here we go. Yeah, so I asked them to. I discovered that dotted lines referring to what? Because you should know what are these loads referring to. Here, probably it would be a good idea to add dotted lines, but probably they didn't do it, probably, or because the original document does not have dotted lines. And even I didn't tell them. So this is what is 1D. 1D, this is the dead load of the fresh concrete. So the load is going to be transferred through the shores all the way to the ground. So the shores, in this case, the shores carrying the entire dead load and transmitted to the ground. And this is the step number 1. Step number 2, place concrete level 2. Now, remember the forms are still here. After a certain number of days, and we can talk about this later on when they can. We go to the second level and put the forms, and we put shores. Also, this is shores, and this is shores. As I told you, they are using vertical solid line to indicate the shores. It is heavier members, and they design it, okay, in the false work manual, they have all this explain it, and this is basically columns and critical load, critical stress, buckling load, buckling stress, the spacing, and how much the load is. So in this case, what is happening here? This is D, and this is also D. We are always express the weight in terms of D. So the load of this is a fresh concrete, and this is hardened concrete. Because the shores are exist, the slab is carrying 0 for sure. Not because it is a fresh, no, because it is supported by the shores. So the shores will carry D, 1D. So the shores at that level will carry 1D. Right now we have the slab of the first level. Here it is 1 and 2. This is, as you know, first level, second level. This is a story 1, story 2, but this is level 1 and level 2. So right now, this here is supported by still, we still have the forms here, and we have the shores. So right now, how much load this slab is carrying 0. The shores of the first level is carrying 2D. D coming from here and D coming from this slab, and this is why this is carrying 2D. And so on. We are moving from one level to another. And for example, this step number 2, level 2 concrete, all loads goes through shores to ground, since slab 1, okay, cannot deflect and pick up any load. The slab will, when we have a slab, concrete slab, and these are the forms. And the forms are supported by the shores. Oops, sorry, here it is. So if the slab is weighing D, and the slab is fully supported by the forms, and the forms are fully supported by the shores at the adequate or at the appropriate spacing, so the slab will not deflect. I need to remember the word, this slab or slabs do not deflect because it's fully supported. Because this is one of the, they have assumption, by the way, when they develop this method, that in preparing shoring and reshoring per this ACI 347, the following assumption should be considered. Okay, structural load, dead load weight of the concrete and the formwork, and there is a lot of stated assumptions, if you like to call it, or consideration. And they added more at the end here in form of assumption. They call them exactly assumption. Number one, all previously cast slabs are identical and have equal stiffness. A ground level or other grade base support is rigid. Shores and reshore are spaced closely enough to treat their reaction, okay, as a distributed load. This is very, very important. Shores and reshores are infinitely stiff relative to the slab, and the reshores are installed snug tight without initially carrying any load. So the reshores, these small members, will be snug tight, just barely against the slab, okay? So they are not initially carrying any load, will be snug tight. This is the reshores, they call it snug tight. So if the slab is fully supported, will not deflect, that means that the slab will carry zero. However, when the slab is hardened, which is a box like this, sorry, I make it like this, but they make it this way, by the way, the fresh concrete. The hollow box is the slab that has been hardened concrete. And we put reshores. The moment that you have this, scenario, these are the reshores. Because before we put the reshores, we took the forms out and we took the reshores, and the slab was not supported with anything. But we start to put the reshores. So the slab will start to deflect a little bit, little tiny. Even a small deflection probably, okay, but still it will deflect. The moment that the slab start to deflect, that means slab start to deflect. Means start to carry load. Okay? And this is the whole story between shores and reshores. What I did in the past, I know it is, I will be glad to scan it and send it to you. I took a sample of 2:1, and I know my hand writing here is a little bit crowded, but normally at the beginning of each semester, or when I touch the subject, come up with one example and go over it. Even I wrote the word snug tight, snug but not loaded, the reshores. I know it is a small, but for this example here, it is 2:1. Okay, it is 2 shoring and 1 reshoring. So when you receive it, I will try to scan it and send it to you also. 2 shoring and 1 reshoring. And this is why when we move, you will find that the 2 shoring and 1 reshoring. Okay, you will find that the X, and we have 2 shoring here. Okay, X, and we have 1 here, but this is empty during the transition. And here is 2, and here is 1, and so on. So here they define the dead load for you that will be included. For example, this here, they are saying that dead load of the slab. Let me see if I can find a nice and a clean one. I know I withdraw this. I asked my staff or my assistant to do it. Let me see if I have it somewhere. No, I don't have this in this book here. Let me look to the other book. It might be there because I always have problems here and there. Yeah, I do have one. I do have one on my AMB on book. Let me see if I can make a copy very quick, and I will send it to you also. The copy machine is not available. It's still busy doing something else. But this is a sample that I will send it to you. And again, yeah, I did. Let me make sure that it's the same sample problem. At least you can follow up with me too. Yeah, but I'm using the new style, which is not bad. Okay, good. Okay, at least it follows the 7th edition. Okay, the 8th edition. Sorry. So this is the 8th edition. 8th edition. 8th edition. 8th edition notation. So what is given here? This will be given to you, by the way. In the problem statement, this must be given. What are the loads involved in this construction operation? Also, he should tell you what kind of shoring and reshoring system is using. For example, this is 2 level of shoring and 1 level of reshoring. So this is, we call it 2-1. 2 shoring and 1 reshoring. Here he said that the weight of the slab is D. The construction life load is 0.5 D. This is L. And the shores and the forms is 0.1 D. And reshore weight are neglected. So this must be given. You cannot assume it. So when they build the first level here, so this is the concrete, this is the D, which is the weight of the slab, and I have a plus 0.5 D, the construction life load is given, and the forms and the shores are 0.1 D. So the total of this, as you can see here, is 1.6 D. 1 and 0.5 and 0.1. So the slab is carrying 0. This dotted line here indicated to the slab. And the shores will be carrying the 1.6 D. And we know the 1.6 D is, as I mentioned, The 1.6D, basically it is the D plus 0.5D plus 0.1D. So this will give you the 1.6D, which is this load here. And this is step number 1. Now we're going to go up. Here, what I have here, I have D, I have 0.5D, I have 0.1D. This is the fresh concrete. Okay, this is the slab number 1. So I have only D plus 0.5D here. Okay, so this is 1.6, exactly as the previous one. I added to 1.6. How did he come at 2.7? 2.7 is the 1.6D coming from the fresh concrete and the slabs and the forms, a plus 1D a plus 0.1D. What is the 0.1D? 0.1D is the weight of the forms and the shores. There is no people here. The 0.5D for the construction life load, they are not here anymore because we don't need them to be here because the concrete has been placed and finished and they are working here. So there is no, this is a life construction people, okay? The people like me and you, and we call it life construction or construction life load. So if you add the 1.6 plus 1 is 2.6 and 0.1 is 2.7. So this is how we get 2.7. So this is a 2.7D. So right now, this is the shores, and these are shores. So, and this is step number 2. And as I told you, they explain it like this. Place level 2 concrete or load goes, or loads, probably much better word, or load goes through the shores to the ground. Since slab 1 cannot deflect and pick up load, construction life load assumed on the top slab only, which is there is no people here, so the construction life load are not here. Okay, and this dotted line to indicate how much the slab is carrying and how much the shores are carrying. Now step number 3 start to work right now. What is happening? Slab number 2, which is this one here, hardened. This was a fresh. Right now it is became hardened concrete. Construction life load is gone because I don't need the people here. So I have only D here. And I have only D here for this slab. And I still have the shores here. Here he is providing you, by the way, with at the beginning, it changed during operation, and the total at the end of the operation. If you add this plus this, must give you this. What are these 3 columns here? They are referring to the loads on the slab. How much the slab is carrying. So for example, at the end, it was 0. This is at the beginning will be 0. We transfer this. And the reason I'm doing this, because if you look to this, you will find that at the end, here is 1.05. It will be transferred here. For slab number 2, 1.05 will be transferred here. So you need to know this process. This right now, the this is the previous, this is the total. Here it is. So the previous here is a transferred here, and this here is a transferred here. Let me transfer all of them. At least you can get the this one here, a transferred here, and this one here is a transferred here, and this is a transferred here, and this is a transferred here, and this is a transferred here. You should know this process, that the total of the previous step is going to be the load at the beginning. Here it is. This is at the beginning. So I took the total, the 1.05, which I'll show you how he got 1.05. The 1.05 will be transferred at the beginning. And during the operation itself, it changed. If there is anything happen, we added here. Here, for example, 0. So 0, so 1.05 plus 0 will give you this. And this plus this will give you this. And the same story, 0 plus this will give you this. And 0 plus this will give you this. And 0 plus 0 will give you this. And 0 plus 0 will give you this. And 0 plus 0 obviously will give you this. You need to know what we are transferring and what we are adding. This is something very, very important. And when you receive my notes, please, okay, look at it. And if I can locate the machine stopped, I believe I can send you a clean copy to do it. So you should know what we are adding and what we are transferring, because this is a key. What we are transferring and what we are, because on the exam he will give you if you remember that the problem I think, yeah, here it is. The problem, here it is. The NCEES problem, which we can cover it later on, probably today. I will not be able to do it because I have to leave. Okay. And I can add another session. I think the first, let me see here, my schedule is really, really busy. And oh, this is the, oh, here it is, yeah. I believe we are going to start construction BE7, I believe July 18, if I'm not mistaken. Let us see when construction will start. Oh yeah, the computer is doing a lot of stuff on the back, so probably takes time to load. Even this is i7 and it has a lot of, but anyhow, here we go. The first day, it will be July 18th. What is July 18th? July 18th on Sunday. So July 18th, I don't know what this is, but anyhow, it seems to me there is something wrong with it. Okay. As long as you are still here, that's fine. So probably I will see if there is a room for any additional session or so, or or one add more, if I can, one free additional session. So in the problem, they are going to give you before the step, this is at the beginning, and they change it during the step and after the step. So this is at the beginning, okay? So this plus whatever it change here will give you this, okay? So you need to be aware of that. So this is what they a little bit load carried by the floor in multiple of D also. They are looking to the slab, okay? And they are telling you on the problem what is a fresh and what is uh, hardened concrete and so on. So we need to be aware of that. So the first thing that we need to be aware of how, okay, let's go to step number 3 to wrap this up. And when you receive it, you can follow the same thing. Step number 3, where the things start to be a little bit, okay. What is happening here? Right now, we removed the shores and the forms. So right now, this slab right now, since we remove the shores, what will happen? It will come down. It will deflect. I'm going to show the deflection a little bit exaggerated. At least you can. Since this is deflected like this, this also will come down because they are. So right now, I have D and D. They are 2 Ds. Is this correct? Nobody, no construction people over there. So I have D here and D here, 2 Ds. I still have the forms here because the shores are still there. And the forms are what? Are 0.1D. So here I have D, a plus D, a plus D 0.1D. Do you agree with me? So the total is 2.1D. So far so good. This slab will take 50% and this slab will take 50%. This is what they are saying, that slabs are similar or equal stiffness. This is one of the assumption. And you may say that this is not true because this is older than this as far as the age, because this was built first and this is second. But they are assuming that all slabs, they have the same rigidity. So this is 2.1D. If you divide this by 2, will give you what? 2.1D is going to be 2.1 over, it will give you 1.05D. And this is exactly what you see. So at the beginning, I did not transfer, sorry, let me transfer, at least I can use the same color. So this, it transfer like this is 0, a transfer here, and this 0 is a transfer here. This is at the beginning. During the operation, what happened here? What is the change from here to here? I remove the shores. So this slab can deflect, and consequently this slab will deflect. These two plus the weight of the forms, which is 0.1D, and the shores, this will carry 50 and this will carry 50%. So this is 1.05D. So I put 1.05D, 1.05D. So 0 plus 1.05D, it's 1.5D. 0 plus, here it is. And this is the step number 3. So far, so good. Step number 4. What we did here, we added the reshores. The reshores, they don't carry any load, just snug tight against this. They are just holding the slab snug tight. You know, so what is the snug tight? I believe the word here, it is snug, but not loaded. The word snug means that's barely okay, just against it. And they do this by adjusting the screw. So in this case, there is no change at all. So it is 0 plus 0 here during this operation, which is the second column here. I have the 1.05 coming from the previous one. 1.05 plus 0 will give you 1.05. 1.05 plus 0 will give you 1.05. And obviously the total here at the end, by the way, here it is. Here, by the way, let me mention here something very interesting. Okay. The 0.05D, what's 0.05D? 0.05, this is a 0.1D, by the way. This is 0.1D. Do you remember that? 0.1D. Okay. So this is D, and 0.1D is 1.1. But the slab is carrying 1.05. That means that this is going to carry 0.05. The shores themselves, they carry 0.05D. The let me write it down here. The 0.05D, it came as a result of what? As a result, the slab is carrying, I have D plus 0.1D minus the slab is 0.05D. This will give you, this is 1.1D, and this is 1.05, will give you the 0.05D. This is how we come up with this number. How the forms, the shores will carry, how much load is carrying by the shores. And the 1.05 already I showed you here. I need you to understand this process because it's not an easy process, as especially for those who are taking construction. We can continue like this. Step number 4, obviously this is an easy, it's not a big deal because no change. Step number 5, and I will stop here and we can continue this later on because I have to leave. Step number 5. Now we are adding another level of fresh concrete. So what I have here right now, I have D plus the people 0.5D plus 0.1D, which is a 1.6D, which is shown here, by the way, 1.6D. So the slab, this is wet, it's carrying 0, 0, 0, 0. Here I have 1.05D came from the previous step, and 1.05D coming from the previous step. And here again the explanation. Always read this, that form, shore, and place level 3 concrete. This is level 3 of concrete. And this is shore, and this shores, and the dotted, as we know, is the reshore. And you are going to see that the reshore start to carry some loads. Here they carry 0, by the way, here it is, they carry 0. Because we place them after we remove the shores, because we can go ahead and build the third level. And this is the benefit of all these things. I need to take the forms and move on. So look at it and you'll find that, and when I make a copy of this, you'll find this is interesting. And as I said, that if I able to add another session in the future, I will not hesitate to do that. So join me July the 4th and I will do my best to help you guys as much as I can. And I hope that you enjoyed your summer, and I did my best to help you during this summer to keep you fully contacted with the subject, and I will do my best to help you as much as I can. So I will stop here because I have to leave right now. I include this, even this is very loud, very messy. I think they will. No, let me include this right now, and we can continue this. But if you follow up with the same logic, it is the moment that the slab start to deflect, that means it start to carry load. This is something that I needed to be aware of it. And I will try to find a clean copy right now. I will find the original. I can send it to you. At least you can look at it. And all this, okay. Okay. So I have to leave right now because as I told you that I will do my best here. And this afternoon I will be here for seismic. So if you'd like to come for seismic, but it's different ID, by the way, it's not the same ID. Seismic class. I don't know if you are interested or not. And this is, I believe, the last seismic class, if I'm not mistaken. Let me see if they have the ID, at least if you are interested to come to learn seismic. Well, okay, so seismic second quarter ID, seismic ID, second quarter seismic. It is a 719. I know I provided before more than once, but maybe some of you are joining me today, the first day, so 035. So basically you type www.joinwebinar.com and enter the ID, and you will be able to join me. Okay. I hope that you enjoyed the lecture today, and it keep building and adding and improving, and I will do all my best to help you. And if there is anything for free in the future, I will be glad to include it. Just check our website from time to time. All these lectures, by the way, are loaded on our website. And I will scan the lectures yesterday and today's lecture, and I will send it to you probably at the end of the day, because I have to leave right now. Okay, thank you very much for coming, everybody. Enjoy your the rest of the day, and stay safe, and I wish you the best. Thank you. Bye-bye.